Next up, we're going to be chatting with somebody who's going to share with us a little bit more on a subject that, I don't know, sometimes this doesn't get enough attention, but it's really important. We're going to be learning a little bit more about building security and quality into our pipelines and how we deliver software. So let's bring in our guest, Jessica Dean. Hi, Jess. How you doing?
I'm doing excellent. How are you, Jason?
I'm having so much fun here today. It's always fun, hosting and chatting with people, learning so much myself, and then interacting with people over in the chat. So yeah, this is great when we ever get to do this. And I haven't seen you forever too. So this is really nice to be able to hang out.
It's been way too long. I mean, of course, I wish it were not pandemic wise, but I mean, this is a perfect alternative.
I feel like we're getting a little bit closer day by day. So hopefully it's not too much longer and we can actually do one of these in person. So, well, I know you've got some really important stuff to share and a lot to cover. So I'm just going to hand it off to you and you can take it from here.
Awesome. Thank you very much, Jason. All right. Hi, everyone. My name is Jessica Dean. And today we're going to do exactly as Jason said, which is we're going to focus on building in quality. Now, first, I'm going to level set here because we've really learned a lot, right? There's been so many fantastic speakers and we've really had to digest quite a bit of information. So let's recap on this journey we've been on. We started off where Brian talked to us about how easy it is to get started with DevOps. Nagan walked us through just how easy it is to manage the flow of work and how we can leverage GitHub and Azure DevOps. Today, in this session, we're going to focus on building in quality and specifically how we can have confidence in the quality that we've built. In the next session, we're going to focus on how we can deliver change. So we're going to continue to build on the skills we've acquired thus far. And then we're going to wrap this entire learning journey up with how you can operate software in the cloud. Now, some general goals for this session. We're going to talk about security, how you can add security into your mindset and into your process. That might be through things like Azure Policy, Azure Key Vaults to store things like secrets. We're going to talk to you about how you can enable certain features in GitHub for security and even for dependency alerts. So you can actually scan your code for any kind of vulnerability issues. Then we're going to move on to how we can add those security best practices into our containers. And finally, where we're going to spend the bulk of our time is how we can build in quality with security in mind and gain confidence in that quality we've built and ensure that everyone on our team gets to have access to that quality. Now, we're going to use an application called Tailwind Traders. Maybe you've heard of it before. Maybe you haven't. Either way, that's okay. It's a fictional e-commerce web store, and it has everything that you would expect in a normal e-commerce website. It has a shopping cart. It has a products database. It has a login API. It has a whole bunch of different services to render that e-commerce experience. And prior to the session that we're going to focus on today, the infrastructure was very traditional. In fact, I'm kind of cloud, right? We kind of had a Docker container running, but it was very monolithic in the way that it was designed and the way that the application was architected. We also were using an older version of .NET Core 2.2 and React. All of that was bundled up into a single container running an Azure App Service. From there, it would connect over to Azure SQL Database and Azure Cosmos DB. However, there were a few things that Tailwind Traders needed. For one, they wanted to get away from the monolithic all code in one single code base, and they wanted to abstract out all the different services. There's quite a bit of services that actually go into ensuring Tailwind Traders is successful. I've mentioned some of them, the shopping cart, we have a coupons API, we have a stock checker, products. We needed to make sure that we had some quality built into how we architect that. We needed to make it easier in the way that we architect it and debug it. And most importantly, we wanted to become more cloud native. So we wanted to start abstracting that architecture for our application out and ensure that we could have infrastructure that could support that abstraction. When you start getting into the world of abstraction and cloud native and microservices, it begins to get a little challenging. So we also wanted to focus on how we could help Tailwind Traders have confidence in that abstraction and in what they're building. And most importantly, now that things are kind of broken apart from each other, but still working together, we wanted to make sure that security was at the forefront. So let's recap of what Tailwind Traders application architecture now looks like. We have the same Tailwind Traders website, but now it's been broken up into 11 different microservices. We've actually moved from .NET Core 2.2 to to .NET 5.0. We're still using React as part of the web front end, along with .NET, and we're still leveraging connections over to Azure SQL Database and Azure Cosmos DB. In fact, a better view of what our application looks like is this. We have our user that connects to our web front end, which is that .NET 5.0 and React, connects over to the backend framework. And from there, we start connecting out to our individual APIs, which can access Azure SQL Server or Azure Cosmos DB. Now, I'm going to walk through how we set this up and how we made sure that our application had secure code and was in accordance with the policy that Tailwind Traders needed, as well as making sure that security was considered for each container, since each API is running in a container. But I'm also going to focus on how, as a developer, when a vulnerability is discovered, or worse, a plain bug is discovered, how you can confidently and quality-wise troubleshoot that and get that fix out into production. So I'm going to have my developer workstation here, and I'm going to work exclusively on the cart API, which is a subset. It's a single container in the context of a larger application. And using Azure Kubernetes Service, as well as Visual Studio Code and an extension we'll talk about, I will actually be able to securely and isolated connect over to the existing service for the cart API and take advantage of all other microservices that help make up this application, so I can troubleshoot a bug that I've just been informed moments before this that we now have in production in Tailwind Traders. So let's go ahead and dive into the demo. We're going to focus on how we can gain DevOps confidence using containers, infrastructure as code, Azure policy, and even things like Azure Security Center and Azure Key Vault. So right here, I'm in my GitHub project right here, and I have a workflow that's already been set up with our deploy infrastructure, build images, and deploy microservice jobs. Now, in deploy infrastructure, this is actually quite robust. This is how we were able to help Tailwind Traders stand up everything they need, which includes things like Azure Policy, Azure Key Vault, and even ensuring that Azure Security Center is enabled on Azure Container Registry. And by making sure that we have all of this in what's called infrastructure as code that's checked in right alongside our application code, we're given a great deal of power. You can see that I'm able to accomplish all of these tasks through a secure way of logging into our Azure subscription. I can proceed through with steps that make sense for deploying this infrastructure, like creating my resource group, creating a virtual network. And when I get down to my setup backend infrastructure stage, I can actually leverage an ARM template. Again, that's in accordance with Azure policy. On this repo, I also have security settings enabled to scan all the code to make sure that any dependency vulnerabilities that are detected, a pull request gets started. So all the code that gets deployed into our infrastructure is also secure. Under build images, we leverage Docker to build our individual images. And on this final stage for deploy our microservices, we're also leveraging Helm, which is a best practice and easy way to deploy those previously built Docker images that are in Azure Container Registry, backed by Azure Security Center, to now get that over securely and safely into our Azure Kubernetes service. You can see all our individual APIs there are all deployed reliably. So much so that every time this pipeline runs, we're going to get the same expected result. And best of all, it runs in under 14 minutes. So now that we've recapped how we got all of this set up, let's talk about the next part of our problem. How do we troubleshoot once a vulnerability has been detected or a bug has been detected? Now I'm over in Visual Studio Code. I have my cart API up, and under extensions, I'm going to search for an extension. This was the older name, local process for Kubernetes. If you're following along, you're going to want bridge to Kubernetes. Same extension, different name. From there, I'm going to navigate to my shopping cart JavaScript file. Down at the bottom of my Visual Studio Code window, I have a link to Kubernetes, which is my Kubernetes cluster. It'll take me right over to the Tailwind Traders application that's running on that cluster. Now you can see the bug in real time. When I go to add a wood table, something tells me it's not working. Instead, I get a single red garden gnome added to my cart. Now that would be great if I wanted a single red garden gnome, but I really wanted a table. So now we want to troubleshoot this bug that's just been identified. Using the existing debugger I had for my node application and bridge to Kubernetes, I can add a second debugger to launch my program using that Kubernetes connection. I can start that debugger, and now Bridge to Kubernetes is going to go over and make that connection to my Kubernetes cluster, to the cart service, and it's going to isolate a test environment for me to start debugging and fixing this problem locally. Remember, my goal is to deliver quality code, and I need to be able to do and debug this confidently in the code that I'm going to fix. You can see that that connection has been made. And now my application is actually going to be available in a container in Azure using my local host. You can see the connection ports over in the real life Docker file that also lives in this repo here. And now if I go over to my shopping cart JavaScript file, I'm going to scroll down to the logic that contains adding an item. I believe that's around line 5051, right here. You can see I have an asynchronous call to add my item to my shopping cart, and it's returning something. Now, since I'm connected to this debug experience with Kubernetes with local code, I can actually set a breakpoint. Now I can click on Kubernetes at the bottom of my screen in Visual Studio Code, and I can go to the Tailwind Traders cart instance that has been isolated with a routing header that is specific to me. So this gives me the ability to start working and building in quality confidently. You can see I have a prefix, Jessica D 7091, and it's just a subdomain of my development application running in Kubernetes. Now I can go to add an item to the cart, and immediately I hit my breakpoint. Since I'm in Visual Studio Code, I have IntelliSense. I can break down the detail of that product, and I can see that sure enough, somewhere I'm getting sent a single red garden gnome. Now I can actually go over to the debugger and start drilling down into my call stack. Now I notice that there's another async function for add product. So I can see right here that I'm getting that doc returned with add item. And if I scroll up just a few lines, I see the problem. It looks like we meant to actually call the request body, but somebody either in development or debugging accidentally checked in code with a hard-coded call with a body stack. So now we have that single red garden gnome that's getting sent. What I want to do is fix line 24 and add in that request.body. And we're going to go ahead and for now, just comment out lines 13 to 23. Of course, in production, we would delete that. And ideally, that wouldn't exist. We just want to showcase the power of this extension. I'm going to go ahead and restart my debugger. I'm going to leave the breakpoint on line 53 because I want to see that IntelliSense again. I'm going to go ahead and refresh the web page here, again, using my prefix, my private environment. I'm going to go ahead and add to cart again. And again, I have hit my breakpoint. Now, when I hover over and I see the detailed product, I see that I'm actually getting sent the item I would expect, which in this case is a microwave. Now, I can continue on that hit of the breakpoint, and we can go over into our shopping cart. I see the microwave, and I still see the older garden gnomes. So we're going to clear everything out, and we're just going to triple check this one more time because I'm starting to get confidence in the fix that I've made. But I want to be 100% sure, and then I want to help others to have confidence. So I'm going to go ahead and remove this breakpoint here. I will refresh my web page, and we'll go find a different item. I'm going to find a coffee maker. I'm going to add that to the cart. And right up there, I get a little notification at the top of the window. I think this worked. There we go. We have our coffee maker in the cart. So now, again, I have confidence in this fix that I've made. But how can I help others on my team have confidence in this as well? I am so glad you asked. Right from within Visual Studio Code, because I've been working on my own Jessica Gnome Fix branch, I'm going to go ahead and check this in. I'll add a commit message, Gnome bug fix, commit, and push. Now, once I push that, I can flip back over to my project in GitHub, and I can actually begin to open a pull request. And we'll talk about what will happen when I open the pull request here. First, I'm going to make sure that I'm attempting to merge it into the proper repository. We'll pretend that I added in my comments and everything, and then I've opened the pull request. Now, once that I have, there's another GitHub Actions workflow that's actually firing off with steps that make sense to test this out in a PR environment. In fact, it's doing a lot of the same steps we did in the first workflow that we kind of walked through. If we drill down into some of the details here, you'll see that I'm still going to be logging into Docker. I'm still going to be using Helm. Let's actually take a look. You'll notice that it's setting up our job right here. It's checking out our code. And I'm seeing some steps for logging into Azure, logging into Docker, building our image, and then it's also going to add some routing headers. In fact, this workflow is doing a lot of the same things that our Visual Studio Code Bridge to Kubernetes extension did. And when it finishes, now everyone who's a part of this PR is going to get the same level of confidence I had locally. Because if you take a look at the URL that gets added thanks to a GitHub Actions bot, now I have that Jessica Gnome fix, which mimics my pull request branch name as a subdomain of our development environment. So everyone who's a part of the pull request, whether they write code, whether they're a PM, whether a designer, now they have confidence in the changes that I've made, in the security that has been made, because anytime dependent bot alerts also create a pull request to this repo to fix vulnerabilities, the same workflow fires off, and we can always go and see the changes live to have confidence in the quality and the security we have built. Now, I know that that's a lot. We've really been on quite a journey just in this short 15 minutes. You can always learn more at Microsoft Learn, and links will be provided throughout today's session. I'm so excited to hang out with you and answer a few questions. And again, thank you very much for having me today. It's been an absolute pleasure and a blast.